transactions or even scientific observations. They're all just sitting there in a simple file.
Right, a CSV or a text file usually.
Exactly. And your mission, get all that into a database fast. But crucially, without crashing your system or, losing any data.
Yeah, that's a classic software engineering challenge, a really common one.
And it's precisely where today's deep dive is going to take us.
This deep dive focuses on, well, how to efficiently upload millions of records from a CSV or TXT file in Java. We're basically pulling insights from a detailed interview guide.
So we're looking at the strategies to prevent things like memory overflows.
Yes, memory overflows, those really long processing times that drive you nuts, and just generally avoiding system instability.
Okay. Our mission today, then, is to equip you, our listener, with the essential knowledge, the key strategies, and maybe even a few surprising bits from this material. Think of it as a shortcut to getting really well informed on this.
Whether you're prepping for a meeting, starting a new project, or just curious about handling big data files, yeah, this is for you.
Okay, so you've got this huge file staring you down. Your first instinct might be, well, fire up the IDE and start coding, right?
Yeah, that's the temptation.
But the guide makes a really strong point. That's often the last thing you should do. What's the real first step here?
It's interesting, isn't it? The best initial response isn't about how to solve it, but asking what needs solving. It's all about clarifying requirements first.
Okay.
It shows you're thinking analytically, considering the real-world constraints before you even touch the keyboard. Sort of like being a detective.
A detective, I like that. Okay, detective, what are the vital clues we need to gather? What are these crucial questions?
Well, first off, number one, destination database. Where is this data actually going?
Right.
Is it MySQL, PostgreSQL, maybe Oracle? Or even NoSQL like MongoDB or Elasticsearch.
Because they all have different ways to load data efficiently, yeah.
Exactly. They have different optimal bulk load mechanisms. Knowing that upfront changes everything.
Makes sense. Okay, clue number 2. What about the file itself?
Right, the file format. You can't just assume it's a perfect CSV. Is it comma separated, tab separated, fixed width, something else? Does it have headers? How does it handle, say, commas inside a field, quotation marks? That stuff really impacts how you parse it.
Definitely. And then what about bad data? You almost never get a perfectly clean file with millions of records.
You usually don't. So data validation and transformation. Do you need to check data types? Make sure numbers are in a certain range. Apply business logic before uploading.
And if so, what are the rules? That adds a whole layer of complexity.
It really does. Which leads straight into the error handling strategy. What do you do when you find bad data?
Do you just stop everything?
Exactly. Stop the whole process on the first error. Or maybe log the bad records somewhere and keep going with the good ones. How detailed do those error reports need to be?
That really defines how robust your final solution is, doesn't it?
Totally. Then there's expected throughput and frequency. Is this a one-time Big Bang upload?
Or is it something that needs to run regularly, like an ETL job?
Precisely. A recurring pipeline might push you towards using a framework like Spring Batch, which is built for that kind of repeatable task.
Got it. And environment matters too, right? Like memory and CPU.
Oh, absolutely. Environment constraints. How much memory do you actually have available? Are there limits on CPU cores? Is multi-threading even allowed or maybe encouraged? This tells you what's actually feasible.
And the last big question you mentioned.
Transactionality. This is a big one for data integrity. Do all millions of records need to succeed or fail together as one single transaction?
Or can you commit them in smaller batches along the way?
Exactly. Committing in batches is usually much better for performance and resource usage, but it depends on the requirement.
Wow, okay. So understanding all of that before you write any code, that's paramount.
Absolutely paramount for success.
So the big takeaway here seems to be clarity is king. Answer these questions first. Get the blueprint right.
Couldn't have said it better myself.
All right, so once we've done our detective work, we've got clarity. What's the fundamental thinking? What's the core philosophy for actually uploading these millions of records efficiently in Java?
Well, the main goals, the things you're constantly balancing, are usually memory management. You can't run out of memory, reducing the back and forth with the database, that overhead, and just getting the highest possible throughput.
Okay, memory, database chatter, speed. Got it.
Yeah. And the challenge is, how do you actually achieve that balance using Java?
And this is where it gets really interesting because the guide suggests combining a few key strategies.
That's right. The core ideas really revolve around 3 things.
First up, there's the streaming approach. Using something like, what, a buffered reader?
Exactly. Buffered reader or a similar mechanism. The point is to read the file line by line or in small chunks, not loading the entire massive file into memory at once.
Which avoids those dreaded out-of-memory errors, right?
Precisely. It keeps your memory footprint low, even for huge files.
Okay, so streaming avoids memory issues. What's next for efficiency?
Then you've got JDBC batch inserts. This is all about cutting down the number of times you talk to the database.
Like sending one big package instead of a million postcards.
Perfect analogy. Every trip to the database has overhead. Sending inserts in batches, say, 1,000 or 5,000 at a time, dramatically reduces that overhead.
Makes sense. Stream the input, batch the output. What's the third piece?
Parallel processing. If your server has multiple CPU cores, and crucially, if your database can handle multiple connections writing at the same time,
then you can potentially speed things up even more by using threads.
You got it. Use multiple threads to process parts of the file concurrently.
Okay, streaming, batching, parallelizing. These three ideas seem to be the foundation for the different approaches we're going to look at.
They really are. They form the backbone.
Cool. Let's dive into the first specific approach then. Approach 1, buffered reader plus JDBC batch insert. This sounds like the basic, maybe most common starting point.
It often is. It's foundational. It balances simplicity with a really significant performance boost compared to just inserting records one by one.
So when would you typically use this one?
Probably for simpler projects, flat data structures, pretty standard CSVs, cases where you don't need super complex validation or data transformations.
And it's lightweight.
Very lightweight. It just needs standard Java SE and JDBC, no heavy frameworks needed, so you can get it up and running relatively quickly.
And the core idea is simple too, right? Read line by line with the buffered reader.
Keeps memory usage low.
And then use JDBC batching, like prepared statement.add batch, and then execute batch periodically.
Exactly. You prepare a statement, add a bunch of records to the batch using add batch, and then call execute batch to send them all off to the database. The guide mentions optimal batch sizes are often somewhere between, say, 1,000 and 5,000 records.
Okay, kind of the bread and butter approach. What are the big pros here?
Well, like we said, it's simple, fast to set up, definitely has a low memory footprint because you're reading line by line. It's efficient with the database because of batching, cutting down network trips. And you have full control over your transactions. You decide when to commit.
Sounds pretty good.
Yeah.
What are the downsides then? Where does it fall short?
The main things are it's inherently single-threaded. It processes sequentially. All the parsing and validation. That's on you. You have to code it manually, which can be error-prone.
Right.
It also has pretty limited built-in fault tolerance. If something fails, you need to write your own logic to handle retries or figure out where to restart.
And no automatic resuming if the whole process crashes halfway through.
Nope. No built-in resume capability. You'd lose your progress unless you built that tracking yourself.
So a great starting point for simpler tasks, but you can see how you might outgrow it pretty quickly for more serious, complex production-level stuff.
Exactly. You hit its limits when things get complicated or need to be really robust.
Which brings us neatly to approach 2. OpenCSV, Apache Commons, CSV, plus Spring Batch. This sounds like it's for those more enterprise-grade situations.
Definitely. This is where you bring in a framework designed for heavy lifting. You'd use this when you have complex ETL needs, extract, transform, load. When you need really robust error handling, maybe complex CSV parsing rules, or significant data validation and transformation logic.
And it helps with things like resuming after failure.
Oh, yeah. It's ideal if you need checkpointing and resuming on failure. It handles chunk-based processing, automatic transaction management, logging, monitoring, basically the stuff you need for production jobs.
Spring Batch uses this reader processor writer paradigm you mentioned. How does that work, basically?
It's a really elegant model. The reader component reads the input data, say, from your CSV file, often using libraries like OpenCSV or Apache Commons CSV to handle the parsing complexities.
Okay.
Then, optionally, a processor component takes each record read, and you can put your transformation or validation logic there. Maybe clean up data, enrich it, check business rules.
Got it. And finally, the writer.
The writer takes the process records, usually in chunks, and writes them to the destination. In our case, that would typically be using JDBC batch inserts to write to the database.
So it separates the concerns nicely. What are the built-in features that make it so robust?
Well, Spring Batch comes with a ton of useful stuff out of the box.
Nice.
Chunking, for starters. It processes items in configurable groups or chunks and typically commits the transaction after each chunk is successfully processed.
Okay, efficient commits.
Retry logic. It can automatically retry operations that fail, like a database write that times out temporarily. Very handy.
Yeah, saves writing that yourself.
Skip policy. You can define rules for skipping records that cause errors, log them, and continue the job without failing the whole thing.
Nice.
Checkpointing and resume. This is a huge one. It automatically saves the job state periodically, so if it crashes, you can restart it, and it picks up right where it left off. No reprocessing already completed data.
That alone sounds worth it for long jobs.
It really is. Plus, it offers great logging and monitoring, giving you lots of metadata and stats about how the job is running. And much of this is set up using declarative configuration, often XML or Java config, which cuts down on the amount of boilerplate code you have to write.
Okay, so the pros are pretty compelling. Fault-tolerant, production grade, modular, extensible, scalable. Sounds amazing. What's the catch?
The catch is mainly the learning curve. Spring Batch introduces its own concepts: jobs, steps, readers, writers, chunks. So there's more to learn up front compared to the simple buffered reader approach.
Right, more setup involved.
More setup, definitely. And it's an opinionated framework. It guides you towards certain patterns, which is usually good, but might feel restrictive if you have a very specific, unusual requirement.
So it's a trade-off. Invest time learning the framework for long-term robustness and features.
Exactly. Are you willing to make that investment for what it offers? That's the key question.
Okay, makes sense. Now let's talk speed. Raw, absolute maximum throughput. That takes us to approach 3, multi-threaded upload with executor service.
Right. This is when you need to squeeze every last drop of performance out of your hardware, especially on servers with multiple CPU cores.
But there are conditions, right? It's not always the best choice.
Definitely not. You'd consider this mainly when you need to parallelize the upload to use those cores effectively, when your input file can actually be split into chunks that can be processed independently.
And this is the big one, I guess.
And when your database can actually handle a high number of concurrent writes without falling over. If the database becomes the bottleneck, adding more threads won't help. It might even hurt.
Okay, so how does this approach work in practice? What are the steps?
Well, first you need file splitting. You have to somehow break your massive input file into smaller parts, either logically, like assigning line number ranges, or maybe even physically splitting it.
Then you assign those parts to threads.
Exactly. Use Java's executor service, maybe a fixed thread pool sized appropriately for your cores, to manage a pool of worker threads. You assign each chunk of the file to a task for one of these threads.
And each thread does what? Reads and writes its own chunk.
Yep. Independent processing. Each thread reads its assigned lines, parses them, and performs JDBC batch inserts for its chunk.
Now, database connections. This sounds tricky with multiple threads.
It's absolutely critical. Connection management. Each thread must have its own separate database connection.
You can't share one connection between threads.
No, that's asking for trouble, concurrency issues, potential data corruption. You need a connection pool, like Hikaru CP is a popular choice. Each thread borrows a connection from the pool, uses it, and returns it.
Connection pooling is key here. Got it.
Absolutely essential. Hikaru CP is highly recommended for performance. It manages the connections efficiently.
And what about errors and duplicate records in this parallel world?
Good point. Error handling and duplicates. You need a robust error handling within each thread for its chunk. And you have to think carefully about duplicates. If multiple threads might try to insert the same logical record, maybe from overlapping splits or retries, you need a strategy.
Like database unique constraints.
Yeah, unique constraints are fundamental. Or using SQL upsert logic that's insert on duplicate key update in MySQL, or insert update are conflicts to update in PostgreSQL to handle records that might already exist.
Okay, so the pros are clear. Potentially much faster on multi-core systems because you parallelize parsing and database writes. It scales well if you add more hardware.
Right, huge speed potential, and it opens the door to distributed uploads across multiple machines even.
But the cons sound pretty serious too.
They are. You're dealing with all the complexities of multi-threading, synchronization issues, potential deadlocks, race conditions. Debugging these can be a nightmare.
And just splitting the file correctly can be non-trivial.
True. And as we mentioned, you can easily overwhelm the database if you're not careful with tuning the number of threads and batch sizes. It requires careful configuration and monitoring.
So great power, great complexity.
That sums it up perfectly. Use it when you absolutely need the speed and have the resources and expertise to manage that complexity.
Okay, we've covered 3 solid Java-based approaches. But what if the data set is just monstrous? Hundreds of gigabytes, terabytes. Or what if even the multi-threaded approach isn't fast enough?
Yeah, that's when you start looking beyond pure Java solutions, or rather, use Java to orchestrate more powerful external tools. Sometimes the smartest Java solution is knowing when not to do everything in Java.
Interesting. Like what?
Well, most databases have their own database native bulk loaders. These are highly optimized command line utilities or SQL commands that bypass a lot of the normal processing path, including JDBC overhead, and load data directly.
Like copy from in Postgres.
Exactly. Copy from in PostgreSQL, load data in file in MySQL, bulk insert in SQL Server, Oracle has SQL Loader. These are almost always the fastest way to get data into that specific database.
So your Java application might just prepare the data file and then trigger this native command.
Precisely. It's often the most efficient route for sheer bulk loading speed.
Okay. What else is out there for really huge scale?
For files in the hundreds of gigabytes or terabytes, especially if you also need complex transformations during the load, you're really entering the realm of big data frameworks. Think Apache Spark, or maybe older systems like Hadoop MapReduce.
They're designed for distributed processing from the ground up, right?
Exactly. They handle splitting the work across many machines, fault tolerance, scalability. It's what they're built for. You typically use Java or Scala or Python to write Spark jobs.
And what about cloud options?
Oh yeah, absolutely. Yeah. All the major cloud providers offer managed cloud data ingestion services. Things like AWS Glue, Azure Data Factory, Google Cloud Data Flow. These services are optimized for large-scale data movement and transformation in the cloud, often with less infrastructure management required from your side.
So for truly massive scale, the answer often lies in leveraging these specialized database tools, big data frameworks, or cloud services.
That's often the case. Know the tools available and when to use them.
Now, shifting gears slightly, this guide we're drawing from, it's framed as interview prep. So it anticipates common follow-up questions an interviewer might ask after you propose one of these solutions.
Right, these questions are designed to probe deeper. Do you really understand the implications? Can you handle edge cases?
Let's run through a few common ones. First up, how do you handle malformed lines? We touched on this, but what's a concise answer?
You'd talk about using try-catch blocks around the parsing logic for each line, log the bad line number, the line content itself, and the specific error. Then, based on requirements, either skip the line and continue, or maybe fail the job. A good practice is often to write these bad records to a separate quarantine file for later analysis.
Okay, solid. Next, what if the file is 100 gigabytes?
First, reiterate streaming, absolutely no loading that into memory. Then immediately pivot to the strategies for massive scale. Definitely consider database native bulk loaders first, if possible. If not, or if complex transforms are needed, Apache Spark is the go-to. If sticking with Java, the multi-threaded approach 3, with careful file splitting, becomes essential, but you'd acknowledge the potential limitations even then.
Good one. How about idempotency? How do you make sure running the upload twice doesn't create duplicate records or cause errors?
Key concept. Several ways. Use database unique constraints. Let the database enforce uniqueness. Implement SQL upsert logic on duplicate key update or on conflict do update, so inserts become updates if the record exists.
Or maybe load to a staging area first.
Yeah, load into a temporary staging table, then use a separate controlled step to merge that data into the final table, handling duplicates during the merge. And importantly, use checkpointing, so if a job restarts, it knows where it left off and doesn't reprocess batches.
Speaking of restarting, how do you resume after failure?
Checkpointing is the answer again. Store the state after each successfully processed and committed batch, like the last record ID or line number. Spring Batch does this automatically. If doing it manually, like in Approach 1 or 3, you need to design this mechanism carefully, perhaps writing a last process point to a file or a control table.
Makes sense. How do you monitor progress on a job that might run for hours?
Several options. You can simply log a message every n records processed. For example, process 10,000 records. For more sophisticated monitoring, push metrics like records processed per second, current batch number to monitoring tools like Prometheus, and visualize them in Grafana.
Right, get some dashboards going.
Exactly. Or if using Spring Batch, leverage its built-in admin UI or metadata tables, which provide detailed statistics on job progress, duration, step execution, etc.
Last one. The database insert becomes the bottleneck. Your Java code is flying, but the DB can't keep up. What do you do?
Okay, now you look at the database side. First, experiment with the JDBC batch sizes. Maybe larger batches help, maybe smaller ones reduce lock contention. You have to test. Then, database tuning. Optimize server settings like transaction log size, buffer pool memory, I/O configurations. Check indexing are the right indexes present. Sometimes, counterintuitively, you might drop indexes before a huge bulk load and rebuild them after, as maintaining indexes during insertion can be costly.
And connection pooling.
Absolutely. Ensure you're using a high-performance connection pool like Hikari CP and it's properly configured. And if performance is still lacking, seriously evaluate switching to the database's native bulk loader utility. That often provides the biggest jump.
And for extreme cases.
For truly extreme bottlenecks, you might need to look at database partitioning or even sharding, but that's a much bigger architectural change.
Great answers. And the guide also mentions asking your own follow-up questions in an interview setting.
Yeah, that's a great point. Asking smart questions back shows you're engaged and thinking holistically about the problem, not just coding in a vacuum.
Wow, what a deep dive indeed. It's really clear that efficiently uploading millions of records isn't just, reading a file line by line. It's a full-on system design challenge.
It really is. It touches on memory management, database optimization, concurrency, error handling, fault tolerance, the whole stack.
You're balancing simplicity versus efficiency, understanding the specific database you're working with, knowing when you need the robustness of a framework, and even knowing when to step outside Java entirely.
Exactly. The right solution depends entirely on the specific constraints and goals. The file size, the data complexity, the required speed, the need for robustness, the available hardware.
So to bring it all back to you, our listener, what's the core takeaway? I think it's approaching any big data task like this with a strategic mindset. Start with those clarifying questions we talked about at the beginning.
Understand the trade-offs. There's no single magic bullet. Each approach has pros and cons.
Right. Understand the trade-offs. Consider the bigger picture of the database, the infrastructure, the operational needs. If you do that, the next time you're facing that mountain of data, you'll have the mental toolkit to choose the right approach and conquer it efficiently and reliably.
Well said.
Thank you for joining us on the Deep Dive.